Hey everybody, we are starting chapter 7 and I'm going to do section 7.1 over 3 separate videos. We have a lot of information to cover in this particular section, so I'm going to get started here. Law of signs is helpful because it helps us find missing side or maybe angle information in non-right triangles. So we've been doing so much focus on trig ratios. Remember that those SOHCAHTOA trig ratios are only helpful if you have a right triangle. So this will give us some options to solve for missing stuff if it is not a right triangle. And just some vocab information here. Those triangles, if they are not right triangles, are called oblique triangles. I know you've heard that before in geometry, but there's a good reminder for you. So our textbook says that we should use sign rule or law of signs. So these phrases are kind of interchangeable. Our textbook calls it law of signs. You should use it if you have one of two conditions, or maybe both. If you have two angles and one side, then you can use law of signs to solve a problem. Or if you have two sides and a non-included angle, you can also use that to solve a problem. Okay, so I have my diagram for my triangle. This is a good time to remind you that rule of thumb is to use capital letters to represent the angle measures. Here I have angle A. The side that is opposite that should also be labeled with A, but we typically use lowercase letters to note that. Here's angle B, and the side that is opposite that should be lowercase b. That's very important to understand the formula. So here is the formula or the setup for law of signs. I kind of have the first one memorized. All you'll notice is very simple. You're going to take the sine of the angle and divide it by the side length that is opposite of that. A with A, B with B, C with C. And if you do that, that ratio is consistent throughout the entire triangle. Kind of interesting. I tend to always set it up like this with my sine of my angle in the numerator, but do know that you could technically invert those things. You could put your side lengths in the numerator and your angle information in the denominator. Either way is correct. So rather than memorize the two conditions that I put on the front page, I think an easy way to think about whether or not you can use law of signs, because we're going to use law of cosines next week, be a little bit different, is to look for this relationship. So in this example, I know the 60-degree angle measure, and I also know the side length that is opposite that. That tells me that I can set up the known ratio. I know that sine of 60 degrees can compare to 7. I have to know one of the side relationship angle things in order to be able to use law of signs. That will help me here because I'm trying to find side x, and I do know the angle that is opposite it. If you didn't know that, you might need to use like triangle sum theorem or something to come up with that in order to do that. Okay, so there is my proportion. To solve a proportion, you're going to cross multiply, and you can probably, some of you do this in your head. I'm going to write it out. X times sine of 60 degrees. I'm going to wait to type all this stuff in until the very end, equals 7 times sine 80 degrees. This is attached by multiplication, so if I want to isolate my x, I'm going to divide by sine of 60 on both sides, which will cancel it out on the left. X is equal to 7 times sine 80 divided by sine 60. And now is the time where I'm going to go ahead and type that in to my calculator and make sure you're in the right mode. And when I did that, I got 7.960, etc. I'll tell you our textbook's rule of thumb for these problems. They want us to round to whole numbers for the degree measures, but then for the sides, they say to round to the tenths. So if you think about rounding, the 6 is going to round the 9 up. So it actually ends up being 8.0 for x. All right. Let's take a look at another example. This one I'm going to solve for angles instead, and then we have additional instructions to solve the triangles. So to use law of signs, you have to hunt down that matching angle and opposite side relationship. Again, that's key for us to be able to use law of signs. So I'm going to set that up. Sine of 100 degrees divided by 5.1 is equivalent to sine of, I don't know it, angle B, but I do know the opposite side, 3.6. So this question is different because I don't know the angle. In the first example I didn't know the side. I'm still going to cross multiply. 5.1 times the sine of b is equal to 3.6 times the sine of 100 degrees. I want to get rid of that 5.1, so I'm going to divide on both sides. So I'm left with sine b equals all that stuff, 3.6 sine of 100 divided by 5.1. And then we do have an additional step because I'm trying to solve for an angle. I need to undo sine. So you're going to use inverse sine of all of that stuff. Now, if you have a graphing calculator like a TI Nspire at home, you're probably safe to type that all in at once. But if you're just using a TI-30 or something, you're going to want to baby step it. So this is how I would do it. Or if you're using your cell phone or something, I would start with sine of 100 degrees, hit enter. Then I'm going to multiply by 3.6, hit enter. Then I'm going to divide by 5.1. Then I do inverse sine and I use my answer recall button, second answer. That way I'm not rounding along the way and I know that I get an exact answer. So the calculator says 44.039, etc. For angles, they want us to round to the nearest whole number. So angle B is 44 degrees. 44 degrees. Okay, we do have additional instructions. They ask us to solve the triangle. So remember that solving a triangle means you find all of the unknown information. You need to find all the missing sides and all of the missing angles. And no, I cannot use Pythagorean's theorem here, and that's because this thing is not a right triangle. So I'm going to start by finding this missing angle. I do know that the sum of interior angles of a triangle equals 180 degrees. So I can find this using triangle sum theorem. And remember, I did round the 44, but we're going to just go with that. I will get 36 degrees. Whoops, I almost wrote 360. 36 degrees. Okay, that's great. So that's helpful because now I know the angle that's opposite this unknown side. I'm going to use letter X to represent that. And I'm going to go ahead and set up law of sines. Sine of 36 degrees is to X as, now technically you have a choice. You could use 44 degrees and 3.6, but I'm going to tell you, I typically avoid that. And that's because 44 degrees was rounded. That was something that we calculated and we rounded ourselves. So I would advise always going back to the provided ratio. I'm going to go back to the sine of 100 divided by 5.1. That was given and that was exact. Cross multiply. X times sine of 100 equals 5.1 times sine of 36. And then I'm going to divide by sine of 100. And I'm going to type that all in the calculator at once. And I did that earlier. What did I get? 3.04, etc. We're rounding to the tenths place, so we can just say 3.0 for this missing side. I have now solved for all of the missing information using law of sines and triangle sum theorem. The last thing we need to cover in this video is it is an area formula. I know you know this area formula. Area of a triangle is 1/2 base times height. But what if you do not have the height, or what if it's difficult for you to calculate the height? You can find the area of a triangle using a sine formula. I believe our textbook provides us with just the one formula, but you have seen these before, or maybe you will see these in the future. I want you to notice a pattern between these, A, B, and C, B, C, and A. What's happening here is we're always doing the included angle, okay? So I have this first formula memorized, the one that I have in the box, and I just kind of apply that to each individual example. That is the area formula for that triangle. So what you need is two sides and the included angle. So here I have 150 meters, or maybe miles, I'm not sure. 231 meters, and I have the included angle. That's a good time for us to use this formula. Now, I know here is angle A. That makes this lowercase a. Here is lowercase c, and we know B. Big B, little c, little a. So we're really talking about this version of that formula. What you're going to do is you are going to set it up, multiplying the two sides together, 231, 150, and then you're going to take the sine of the included angle. Very simple. And go ahead and type that into your calculator. Again, don't do any rounding until the very, very end. And I did it, and I know it's a big number, but I don't remember what it is. I got 14,529.96, etc. If I round this to the tenths, that's going to bump that up to a 30. So I'm going to say about 14,530 square meters. Now, before I let you go, I do want to point out, some of you might be saying, well, couldn't I find the height? In fact, I was looking at the IXL options for this particular concept, and IXL doesn't use the sine formula very much. They instead drop a perpendicular out here, and they have you find the height, maybe by using supplementary angles. For instance, I know that that has to be 180 degrees. It's a straight line. So if I were to subtract 123 from that, that would be 57 degrees. What I could do is use trig ratios to find that height. This would be equal to the sine of 57 degrees times my hypotenuse of that red triangle. Now I'll tell you, if you do that and you don't round it, and then you go back and you use 1/2 base times height, you actually get the same answer. And that's because this formula is doing all of that for you in a very roundabout way, okay? So either way works, okay? But I do think that the sine formula that we just went over is a little bit quicker when you're given the two sides in the included angle. So I'm going to stop there. You have some textbook problems. I got some IXL. That's basically for the law of sines stuff. And then I have a few textbook problems for solve the triangle and also for the area questions.